Yes. The next important concept is joins, guys. Let's continue with joins. Before going to this, let's have a small discussion on this table. That there is a table with two columns. If you ask a query, fetch rows from table with values of A less than 6, that means these three rows will be selected, these three rows will be eliminated because the condition is only on A column. How to write? Simple. Where A less than 6. Fine. Generally, we write any value A greater than 6 or A less than 6, but at times queries may be asked like this. Fetch rows where A and B are identical. That means in this case, condition involves both the columns of same row. In such case, look at this, A and B are identical. SQL is a row by row comparison, row by row processing. So you can write any logic, you can compare blindly two columns, guys. Because in joins, these two columns belongs to different tables. If you want, you can write on same table also. This is how it will be selected. Similarly, another type of query. Look at this with age and marks. Fetch students whose marks are same as age. That means this one and this one to be selected. Again, I will fetch this row. In this row, I will write the logic age equal to marks. Yes, that has been selected. Not only equal to, you can write any logic where marks greater than age. Marks greater than age. These two rows will be selected. SQL is a row by row processing, guys. Yes. Now, whenever you want to fetch data from multiple tables, the only option is joins, guys. There are 8 types of joins. Cartesian product, equijoin, non-equijoin, self-join, left outer, right outer, full outer and natural join. Total you have 8 types of joins. Among these 8, the Cartesian product is the superset, guys. It is the superset. So whatever joins you write, it is a subset from this. It is a subset from this. So please understand Cartesian product first. Then you will understand everything easily, guys. Frankly speaking, the entire thing is a row by row processing from Cartesian product. Let's start with Cartesian product. Here there are 2 tables, guys. If you take the Cartesian product will be divided by cross. This is mathematics, guys. In SQL we don't write any cross symbols, just mathematics I am explaining. If you consider this table, number of columns will be 1, 2, 3, 4 and 5. Number of columns are 5 and number of rows will be 3. Similarly, if you consider this table, number of columns will be 2 and number of rows will be 3, guys. So employee will be denoted with black and department denoted with red. So number of columns will be added, guys. It is 5 plus 2, 7 columns. Black denotes employee table, red denotes department. Actually, it's not a table, it's a Cartesian product. And what is Cartesian product? Simple. All rows of first table will join with all rows of second table. That means if I take this row will join with entire table. That means if you take employee 1 will appear 3 times in Cartesian product. 3 times in Cartesian product. 1, 2 and 3. One with employee 1 with department 101, 102 and 103. Similarly, employee number 2 also appear 3 times in Cartesian product. 3 times in Cartesian product. 1 with 101, 1 with 102 and 1 with. Similarly, employee number 3 also appear 3 times in Cartesian product. 1 with 101, 1 with 102, 1 with 103. This is called Cartesian product. All rows of first table will join with all rows of second table. So number of rows will be multiplied, guys. Number of rows will be multiplied. So when you take Cartesian product, number of columns will be added, number of rows will be multiplied, guys. It is the Cartesian product. So whatever logic you write, whether it is equijoin, non-equijoin, self-join, all are fetching subset from it. So please never ever think these are two tables. It is a single table that is called Cartesian product. So please assume that it has a single table and apply logic, write logic like row by row processing. For example, make this as E and make this as D. So E dot D number is equal to D dot D number. Likewise, you write the logic, but always consider this Cartesian product is a single table. Now, for explaining other types of joins, let's take three tables. It is the employee table, first table. Next, here is the department table, second table, and the last one is the job grades. I am taking three tables to explain the concept. Now, if you take grades, grade will be A if salary is between this one. Grade will be B if salary is between this. Grade will be C if salary is between this. Now here, if you take employee number 1, his salary is 500. So he belongs to A grade. Employee number 2, salary is 2500. He belongs to B grade. Likewise, you have to fetch various data from different tables, guys. Now, other 7 types of joins will be explained by 7 queries, guys. Will be explained by 7 queries. We'll go ahead with each and every query. Yes. The first query, fetch employee information along with department information. What I require? I require output like this. Employee number, employee name, department number and department name. If you take employee number, employee name is available here, department number also is available, but only thing missing, that is department name is here. So when you need data from multiple tables, the only option is go and write the Cartesian product. So number of columns will be added, number of rows will be multiplied. So it is the Cartesian product. Let's make this as E, this as D. There are 9 rows. Now tell me, which rows are required? In Cartesian product, employee number 1, if you take, he joined with all departments. Now I requested, employee number 1, please join with only your department. Don't stay with all departments. Yes, sir. So how do I know? My department number should match with his department number. Yes, matched. So this row I require. This row I require. Whereas this one not matched, this one not matched. So that row will be selected. Next, employee number 2. What have you done? Sir, I joined with all departments. Please join with only your department. Don't stay with all. Okay. This one not matched. Yes, this one matched. This one not matched. Yes, sir, I need this. So he is not working. Employee number 3 is not working. So you will get this data. So how to write the logic? There is the column. So only these 2 rows matching this condition. That means if you take E, E dot D number is equal to D dot D number. Please always consider this as single table. The Cartesian product is a single table. On Cartesian product, please write row by row processing. Consider this as single table. That means from write these 2 tables EMPE and DEPTD. That means this is considered as a single table. From that row by row processing, E dot D number is equal to D dot D number. Whatever columns you require, please write with subscripts. That's it. So it is called as equijoin. Joining 2 or more tables using an equality operator is called as equijoin. Here I joined 2 tables. Here I joined 2 tables. So minimum conditions required will be 1 condition minimum required, guys. Maximum you can write anything, minimum. Similarly, if I join 1 more table, I'll get 1 more condition. If I join 1 more table, I'll get 1 more condition. So to join n tables using equijoin, Minimum number of conditions will be n minus 1 guys. Maximum can be infinity, but minimum should be n minus 1. So it is called as equijoin. Next, here is this time I want to fetch employee information along with grades. Hey, employee number, employee name, employee number, employee name, salary, and I need the extra column that is called as grades. These three columns I found here, but grades I have to fetch from other table. In such case, you don't have any option. You have to go for joins. Number of columns will be added, number of rows will be multiplied. That is a single table, that is Cartesian product. So let's call this as E, this as J. Fine. Total 9 rows. Which row required? Now let's go ahead. Please call employee number 1. Employee number 1, what have you done? Sir, I joined with all grades. Now I requested, please stay with your grade. How do I know? My salary should be between this. Yes. So this one I require it. How about here? No. No. That means I'll stay with only this sample. Similarly, I called employee number 2. Here, what have you done? Sir, I joined with all grades. Please don't do that. Please stay with your grade only. That means my salary is 2500. Is it between this? No. So this one I don't require it. My salary is 2500. Am I between this? Yes. So please keep this. And next one also, remove it. Then I require this. Similarly, I called employee number 3. Here, what have you done? Sir, I joined with all grades. Please don't do that. Please stay with your grade. My salary is 15,000. It is between this only. Not between this, not between this. That means I require this. Then how to write this logic? You have to select only these 3 rows from the sample. That means the condition is on this one. That is E dot salary between J dot low and high dot salary. It is called Cartesian product. It is a single table, that is Cartesian product. Employee and job grades J. So this is a single table. It is a single table with 8 columns. With 8 columns. 8 columns. That is 5 plus 3 and 3 into 3. That is 9 rows. 9 rows. Though you joined 2 tables yet, please consider it as only one table with Cartesian product. Then you have to write E dot salary between J dot low and J dot high. So whatever columns you require, you can write with subscripts, that you will get it. The major logic is writing the where condition. It is if between is not comfortable, you know other way, greater than or equal to and less than or equal to. It is called as non-equijoin. Using an operator other than equality, joining 2 or more tables using an operator other than equality, it can be greater than or equal to, less than, anything. That is called as equijoin, non-equijoin. Equijoin happens only between child and parent column, guys, whereas non-equijoin, it happens between any columns. Next join. Fetch employee information along with manager's info. That means anyhow he doesn't have manager. Employee number 2, his name is B. His manager is 1. What is his name? His name, go and fetch here. That is A. Employee number 3, his name is C. Who is his manager? 2. His name is B. So I need data like this. Employee number, employee name, and manager number, manager name. I require like this. Now here, if you observe here, manager is a foreign key referring to employee number. Manager is a foreign key referring to employee number. So it is also type of equijoin. As child and parent column existing in the same table, then you have to consider one more table. You have to consider one more table. Please consider all the complete table as all employees, and please consider this table as all managers. It's assumption. Now I asked all employees, please join with all managers. Please go for Cartesian product. Go for Cartesian product. Yes. Make it as employee E. This is manager EM. total 9 rows again. Now which row required? Now asked, employee number 1, what have you done? Sir, I joined with all managers. Anyhow, he doesn't have any manager, leave it. You don't have any manager, please remove everything. Okay sir, removed. Now I called employee number 2. Sir, what have you done? Sir, I joined with all managers. Then I requested, please stay with your manager only. Okay sir. How can a manager? My manager number should be that person employee number. Yes, it is matching. This one not matching, this one not matching. Okay sir, this row selected. Similarly, employee number 3, please stay with your manager. Yes sir, so this one is matching. Likewise, you have to write the logic. Please consider this as single table, employee and manager M. So obviously then it will give the Cartesian product. From that you have to fetch row by row processing and select only requested rows. That is E dot manager number is equal to M dot E number. M dot E number. It is also equi-join guys, but both tables are same. Joining a table to itself, it is called as equi-join. Equi-join always happens between child column and a parent column guys. So it is a child column referring to parent column. So equi-join always happens with the child and parent column, that is foreign key constraint. Yes. Now the most important type of join is equi-join. We already covered. Here I have let few more things to discuss. First, sir, there are 3 employees, okay, but when I perform equi-join, how many I got? Only 2. Who is missing? 3 is missing in result of equi-join. Similarly, I have 3 departments. In equi-join, how many departments I got? Only 2. So 1 or 3 is missing. That means in equi-join, I am not getting all employees and all departments. I am not getting this information. I cannot see all employees and all departments. Why? Because he is not working. And why missing? Because he doesn't have any employees. So now you have to understand one point, that is there are 2 types of employees, working employees and free employees. Similarly, there are 2 types of departments. Departments having employees, departments doesn't have employees. So in case of equi-join, you won't get free employee and you won't get free departments. You will get only working employees and you will get departments having employees. But at times I'll ask queries, fetch all employees with their department information, That means if you have department, bring it, otherwise show null. So whenever I ask all employees, I won't get with this equi-join. In equi-join, I'll get only working employees. Equi-join provides only working employees, whereas I won't get this free employee. So in order to get free employee, you have to go for outer join. Here, left table, if you write the where condition here, it is called as left table. Whatever you have written left side, it is called as left table. Later on, you have written right table. Now, instead of equi-join, outer join is an extension. Outer join is an extension to equi-join. Outer join is extension equi-join. If you want all employees, you have to put the same condition. Here you have to write left outer join. Then you get this plus free employee. Those things we'll discuss now. So whenever you want free employees or free departments or both, you have to go for extension of equi-join, that is called as outer join. We'll go ahead. Here is the free employee. Now what I want? Fetch all employees along with department information. I need like this. These two are working employees because they have department information, whereas there is a free employee, it will be shown as null. So how to get this? If this is the result of a equijoin, this is the result of a equijoin. If you perform equijoin, you will get this. Plus, if you want this, you have to go for left outer join, left outer join. Left outer join. That is rows of equijoin plus free rows of left table. That is left table, I am writing it as free employees. It is the result of equijoin plus need this. So, what I have written, this condition is same, that is equijoin. If I write left outer join, whatever left table, those free rows will come. Those free rows will come. So, it is extension to equijoin, guys. Similarly, if I want all departments, instead of left, I have to write right, or I can swap this, but I will go for other join. This time, here is a free department. Fetch all departments along with employee information. That means I want this department also. If there are no employee, you have to show like this. Right outer join. Rows of equijoin plus free rows of right table. It is an extension, guys. There is a result of equijoin plus this one I should get. This one I will get with equijoin. If I want this, I have to perform right outer join. That is right side table is this one. The same equijoin. Clear? Yes. Next time, if I want both, fetch all employees along with all department information. In such case, I have to go for full outer join, guys. I have to go for full outer join. Rows of equijoin plus free rows of left table plus free rows of right table. I did full outer join, guys. So, all are nothing but extension to equijoin, guys. So, equijoin is the most popular join. Sometimes some textbooks will call equijoin as inner join. Words may change, guys. Equijoin is the most popular join. Type of equijoin is called as self join. When both tables are same, all are equijoin only. The last important join, that is natural join. Here are two tables, R and S. Look at this. It is the most popular join, natural join. Here, if you observe R natural join S, I will not write where condition. Where condition need not write. There won't be any where condition in natural join. You need not write it at all. Then how join happens? Natural join is nothing but performs equijoin. It is also equijoin. Without writing where condition, it performs equijoin on similar column names in both tables. If you observe these two tables, each having 3 columns, but how many columns in common? B, B, C and C. A and D are different columns. That means 2 columns are in common, B and C. Then where condition will be constructed implicitly, that is R dot B is equal to S dot B and R dot C is equal to H dot C. So, where condition will be constructed automatically, guys. Now, what is the result? If you want to find the result, obviously it is also equijoin. Let us perform Cartesian product. R Cartesian product S. Number of columns will be added, number of rows will be multiplied. So, 6 columns and 9 rows. Here is the Cartesian product. 6 columns and 9 rows. It is R, it is S. 6 columns and 9 rows. On this Cartesian product, whichever rows satisfies this condition, that will be selected. Perform row by row processing. Yes, R dot B is equal to S dot B, and so this one selected. Next one, first condition eliminated. Eliminate. First condition itself eliminate. Eliminate. Yes. And the second condition, yes. So, this one select. Next one eliminated. Next one eliminated. Next one eliminated. Yes. And yes. So, this one was selected. So, out of 9 rows, only 3 rows selected this condition. The beauty is if you write it as natural join, common columns will come only once in the result set. Common columns, that means what is the result set? 1, 2, and columns will come only once. So result will have only 4 columns, guys. Common columns will come only once. That is natural join. Now somebody argues with me, sir, natural join is nothing but equi-join with this condition, yes or no? Yes, look at this. It is the Cartesian product if I leave like this, where r dot b is equal to s dot c. Now I'll ask, are they not same? If you write natural join, common columns will come twice. Common columns will come twice. Number of rows will be same. Number of rows will be same. 3, 3. But number of columns, with natural join, common columns will come only once. With equi-join, common columns will come twice. Now you have to understand 2 exceptional cases of equi-join. Look at this. In the first case, R and S, there are no common columns. These two columns are different. What happens in this case? And one more case. In this case, common columns are available, but one is a capital data type, other one is a numeric data type. Then what it behaves? These 2 cases you need to understand. So whenever I write R natural join S, if there are no column in common, simply, sir, in natural join, whenever I write natural join, I construct a where condition automatically with the similar column names. And then I'll execute this condition. On Cartesian product. Here, as there are no columns in common, so all rows from Cartesian product will be selected. That's it. So whenever I write natural join, I'll manufacture one condition and execute this condition on Cartesian product. If there are no rows in common, no columns in common, every row from Cartesian product will be selected. That's it. So result will be Cartesian product, guys. If there are no columns in common, the result of natural join will be Cartesian product, guys. Next, in the second case, columns are common but data types mismatching. In such case, it generates an error, guys. Such case, error is generated. Trying to convert character into number, which will fail. These 2 things you have to understand. Next, we'll execute all types of joins on small sample. Here is a R1 table with 2 columns and 2 rows. Here is a R2 table with 2 columns and 2 rows. Small sample. Let's perform all types of joins. I am writing the query. You please tell me what kind of join is it. That's it. No where condition. What kind of join is it? Just I have written select star from R1 comma R2. I didn't write any where class. That means it gives Cartesian product. So number of columns will be added, number of rows will be multiplied, guys. So 2 plus 2, 4 columns, 2 into 2, 4 rows. That is Cartesian product. If you write any query without where class, that is called as Cartesian product. So it is the superset. It is the superset of all types of joins. Next, what kind of join it is? Equi-join. So please perform row by row join. First row, process first row, R1 dot A is equal to R2 dot A. Yes, matching. Second row, not matching. Third row, not matching. Fourth row, not matching. So I processed 4 rows and selected only 1 row. Next, what kind of join is it? It's a natural join. It is also a type of equi-join wherein which common columns will come only once. It's a type of equi-join where common columns will come only once. That's it. Here it is left outer join. Nothing but equi-join. It's a equi-join plus free rows of left table. Free rows of left table. What is a free row? 3 comma 7. Free rows of left table. That is 3 comma 7. Free rows of left table. This time right outer join. It is a extension to equi-join plus free rows of right table. That is 4 comma 9. 1 is already participated, guys. 1 is already participated in join. 4 comma 9. Yes. Next, full outer join. It is called as full outer join. It is equijoin plus free rows of left table plus free rows of right table. That is left and right union gives full outer join. Yes, these two are subsets of this. When you perform union of these two, you will get full outer join. That also you can understand. Next, you know natural join and you know full outer join. At times they will ask full natural outer join. Full natural outer join. It is nothing but natural join extension. What is natural join? Natural join will have three columns A, B, C. The first row will be 1, 5, 7. It is the natural row. Yes, it is nothing but natural join product. Next, full outer join. What is the left free row? 1 is already participated in left. That is left is 3, 7. That is A and B. 3, 7. Next, what is the free? Right, 4 and 9. That is A and C. A will be 4 and C will be 9. So, C will be 9. That's it. It is called as full natural outer join. The only thing is common column will come only once. This one will be null. This one will be null. Natural join plus outer join. Free rows of left table plus free rows of right table, guys. Is full natural outer join. So, whenever you give this kind of queries, don't confuse, guys. Everything is an extension to equijoin. Equijoin matched rows plus free rows of left table, that will be left outer join. Free rows of right table, that will be right outer join. Combine both, full outer join. Now you have to understand key points. From now on, whenever you see multiple tables, that is select whatever I write, it doesn't matter, from, for example, R1, R2, R3, R4. If I write 4 tables with where condition, please never ever say I joined 4 tables. Please always visualize Cartesian product. Number of columns will be added, number of rows will be multiplied. As long as you think the concept in different tables, you cannot understand the concept. So please always start visualizing the Cartesian product. There are no more tables, no more multiple tables. There is only one table, which is Cartesian product. Once you visualize Cartesian product, all queries on joins will be pretty easy for you. Then you have to understand what is the difference between natural join and equijoin. In natural join, where clause is optional, you do not write it, and common columns will come only once. Next, there are 12 rows in EMP table and 0 rows in department table. What kind of join is it? It is Cartesian product. It is Cartesian product. Then how many rows will come? If you are good at mathematics, 12 into 0, number of rows will be multiplied, that will be 0. Please don't give 12. It's a simple mathematics. All rows in first table will join with all rows in second table, but there are no tables as there are no rows in department table. So I don't have anybody to join. In such case, nobody will exist in the set. It is set theory. If one set is empty, the result of Cartesian product will be always empty. That means while applying joins, if one table is empty, the result of Cartesian product is always empty. Next, there are 1000 rows in child table and 2000 rows in parent table. What kind of join is it? It is a popular join, that is equijoin. It is the popular join, that is equijoin. Then when minimum comes, when maximum comes. The question is beautiful, guys. If you take employee table, here is employee table, here is the department table. Employee table will have E number, E name, other columns I am not writing, guys, and department number. First parent table, it is parent table, first parent table to be created, sorry for writing, it is parent table, with D number, D name. Yes. Let's write 3 departments, 101, 102, 103. Some MCA, MBA, MSc. Now I am inserting employees. 1, 2. I'll put this also 104, 105 also. Let's keep more departments. MCom, MA, likewise 5 departments. Parent table has 5 rows. Employee table, let's create, it's a child table. It's a child table. It has 3 rows. Let's create 3 rows. 1, 2, 3. A, B and C. Now please tell me. It is a foreign key referring to this one. Now, you know it is a foreign key. You know foreign key accepts null if all employees are free employees. So, null, null and null. What is the condition here? He dot d number. This row will join with all rows. As nothing is matched, this row not selected. Similarly, the same happens with this one. If all are free employees, nothing will be selected. Because one row will join with all 5 rows, but condition is not matched. E dot d number is equal to d dot d number. No row matches this condition. So, result will be 0. So, minimum will be 0 with foreign key all null values. Foreign key all null values, guys. Clear? Yes. Then how about maximum? How about maximum? Maximum comes only if all are working. For example, he is working in 101, he is working in 102, he is working in 103. So, this row will join with all departments and 101 will be selected. So, 1A, 101, 101, MCA. Yes, first row. First row joined with 5 rows, selected only 1 row. Similarly, 2B, 102. This also joins with all 5 rows and selects only 1 record, MBA. 3C, 103. This one also joins with all 5 departments and selects only with this sample, 103, MSc. So, ultimately all employees selected. So, maximum means all employees will be selected. So, maximum comes always from child table. That is the number of rows in child table. It is the number of rows in child table. So, minimum maximum depends purely on the foreign key constraint. So, if all are free employees, minimum will be 0. If all are working employees, then maximum comes, which is all employees. So, that point please try to understand in a different way. It is the minimum case, it is the maximum case. Minimum comes if all are free employees, maximum comes if all are working employees. Here is the parent table which has 5 rows. Parent table which has 5 rows. Here is the child table which has 3 rows. Foreign key. If all foreign key takes null, the entire logic depends on what values you will be given to child column. So, here this row will join with all rows in Cartesian product. But when you apply this condition, E dot D number null not matches with anybody. So, no rows will be selected. So, minimum will be always 0, guys. When maximum comes, if all are working employees. So, this row will join with all rows in Cartesian product 5 times. But whichever condition matches, only this combination will be selected, others will be eliminated. So, 1 row will be selected. Similarly, this table. So, only 3 rows will come. So, minimum will be 0. Maximum always comes from child table, which is nothing but number of rows in child table. So, in this case, what is child table? Employee is the child table which has 1000. So, maximum always comes from child table, guys. This point you have to understand. The next case, if I say, if this is a foreign key, If I use one more extension, it is foreign key plus not null. If it is also not null column, if not null constraint is implied, then what happens? Null is not accepted. Every employee must take department. In such case, minimum and maximum, there won't be any minimum case because all are working employees. In such case, minimum maximum is equal to rows of child table. That is the extension I am explaining. Look at this. Number of rows in child table 1000. Foreign key is not null as well. In such case, minimum and maximum always comes from child table, guys, because there is no free case. Foreign key cannot take null value. This foreign key shouldn't take null values. Null is not allowed. On top of foreign key, it must take one value from this one. So all employees must be working, guys. All employees must be working. In such case, minimum maximum always comes from child table. Clear? Yes. The next one. Total number of rows in employees M, department is N. Joining. I didn't mention, it can be Cartesian product or it can be equi-join, it can be non-equi-join, any type of join. It can be outer join, it can be left outer join, any type of join. I didn't mention what kind of join it is. Then what is the minimum and maximum? Minimum always 0, with equi-join no rows matching. Maximum is a superset, that is always the Cartesian product. Maximum is always the Cartesian product. Please always remember, guys, the superset of joins is Cartesian product. Whatever query you write in joins, you are trying to fetch a subset from Cartesian product. Yes. Now continue with the questions. Please continue with this question. This was given in GATE 2004 for 1 mark. Whenever you see any question in joins, please understand first what is parent table, and what is child table. First you have to understand these two. What is child table? This what is parent column? What is from this? What is child column? Then try to answer, guys. Without identifying this constraint, please don't answer any question. And one more thing, sir, in few questions they will be given constraints like primary key, foreign key likewise, but in this question they didn't mention anything. The constraints can be specified in 2 ways, guys. Constraints they'll specify in question in 2 ways. One way is they'll give description in question itself. They'll give description in question itself. In question means they'll underline this primary key. They'll write primary keys are underlined. Likewise. Or at times they won't give the description. Such case they'll say table belongs to company database, tables of company database. Whenever they apply this table to some business, then constraints are built in, guys. So you can assume primary key and foreign keys always, because it belongs to business. They fetch the tables from database. Database means the design is completed, then tables created. So constraints are built in. In this question they didn't mention any constraint, so please ignore this. So no constraints are given. So no primary keys, no foreign keys, no primary key, no constraints are given, no primary keys and no foreign keys in this question. All are normal tables. Now look at the question. Here is the student table, department table. They inserted 2 rows in department. They inserted 3 rows into student. What kind of join is it? There is no where condition. That means join is Cartesian product. They are asking what is the result in Cartesian product. Simple. Number of columns will be added, number of rows will be multiplied. That is Cartesian product. So student table will have 3 columns, 3 rows. Department table will have 2 columns, 2 rows. This join is Cartesian product. So number of columns will be added. That is 3 plus 3 columns, 2 columns, 3 plus 2, 5. Number of rows will be multiplied. 3 into 2, that will be 6, guys. So employee number 1 you will see in 2 departments likewise. So answer will be D, guys. It's a straight question, guys. So let me complicate this question. So I want to modify this question. Please allow me to do that. Modified. This case constraints are built in. Look at this. Underlined. Underlined are primary keys. And foreign key is also given. So it is the parent table. So it is the parent table. It is the child table. Please tell me the order first. Parent table to be created first. Child table to be created second. Parent data to be inserted first. Child data to be inserted second. Now look at this. I am executing queries in this fashion. I am trying to insert into child table. Student is child with department 101. I am trying to insert into child table with department 102. Child table department 101. Then I am inserting parent table, that is 101. Then I am inserting parent table 101. Now totally 5 inserts I have done. 3 into student table into. So M is the number of rows inserted into student table. N is the number of rows inserted department table. What is the value of M plus N? These 3 rows I try to insert into student, which is child table. These 2 rows I try to insert with parent table, that is department. Now tell me what is the result? Guys, if you observe here, parent data to be inserted first, then child data. But here I try to insert child data first with no parents, So this will fail because no parent existing, because this table is empty, with no parent. This also fails, no parent. If it is null, it's okay. Instead of department number, if you give null, it will be inserted. But here you give department, it is also fails. So all records into child will fail because parent records are not existing. Now parent record, insertion into parent is always successful. That means these 2 queries, if you write on top, then all these 3 will succeed. As you reversed, as you inversed, so it will fail. So number of rows in student will be 0, child table, everything will fail. This will succeed. So it will be 2, guys. Clear? So please remember the order. Parent table to be created first, child table to be created second, parent data to be inserted first, child data to be inserted second. That order you have to follow every time, guys. It's only one constraint, guys, foreign key, but it creates huge impact on many questions. So you have to be very good at that. Next, it's a 1999, guys, very old question. R has M rows, S has N rows. The maximum and minimum joins. This is always from key points. Every key point is a gate question, guys. Minimum will be 0, guys, with no rows matching in equijoin. Maximum will be always Cartesian product, M to N. Look at this question. This was given in GATE 2011 for 2 marks. So it is a question on natural join, guys. It is a question on natural join. So they want you to join S natural join versus T. What is S? These 2 they called it as S. These 2 columns they call it as S. And bank manager loan amount, that means these 2 columns they call it as T. So one table they call 2 columns as S, other 2 columns are T. The common column is bank manager, which has to be natural join. Now how many rows will come after executing this? So it's a very easy questions, guys. Table with data is given and you have to execute this query on this table and fetch the number of rows. In many GATE questions, they won't give table with data, guys. They'll give this query and ask you to find the question. Reverse engineering they'll ask, not forward engineering. Let's take this. Here is the data, the question. Let's try to solve this by writing Cartesian product. Please write Cartesian product. First, what is S? These 2 will be S. Yes. These 2 will be T. Yes, S and T. Now write Cartesian product. S cross T. That means this row you will see with 3 times. Similarly, this row you will see with 3 times. This row you will see with 3 times. That means number of columns will be 4, number of rows will be multiplied. That is 9. Please write Cartesian product. Just pause the video and write Cartesian product showing Cartesian product consists of 2 plus 2, that is equal to 4 columns, and 3 into 3, that is equal to 9 rows. Please try to write the Cartesian product for first question. It is borrower, it is bank manager, it is bank manager, it is loan amount. I am writing short forms, guys. I am writing for one sample. Writing. This part I call it as yes, this part I call it as T, just for writing logic. So I am writing only for one sample. So this row will repeat 3 times, So I am writing Ramesh, 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 Ramesh. Next one is Sundar Rajan. Sund, I am putting Sund. So I have written 3 times. Now one with this combination, that is Sundar Rajan. Loan amount is 10,000. The next one will Ram Gopal. Loan amount is 5,000. Next one is Sundar Rajan again. What is 7,000? So this row you will see with 3 times. Likewise, I will repeat with this, I will repeat with this also. So total 9 rows, guys. I am directly showing here, guys. You please write on book. Yes, 9 rows. Now you have to perform natural join. Natural join is nothing but the common column is only one, that is bank manager. So you have to fetch rows satisfying S dot bank manager is equal to T dot bank manager. Row by row processing. First row, yes, matched, very good. Second row, not matched. Third row, matched, very good. Fourth row, not matched. Fifth row, matched, very good. Sixth row, not matched. Seventh row, matched, very good. Eighth row, not matched. Ninth row, matched, very good. So that means out of 9 rows, 5 rows matched. Common columns will come only once in natural join. That is how you have to solve by using Cartesian product. As it is the first question, please write the Cartesian product, because we don't write Cartesian product from next question onwards. We try to simulate the Cartesian product. We always try to simulate the Cartesian product. Now look at how to solve. Answer will be C, guys. Next thing. This time let's visualize Cartesian product, guys. Simulating. I don't write it. Look at it. H natural join means common columns will come only once. So here is the output I have to write. Here is the output I need to write. Yes. I don't write Cartesian product. I'll just visualize. This row will join with all 3 rows. Then condition. This condition. First sample. Yes, matched. First sample matched. Very good. Second sample. Second sample not matched. Remove it. Third sample, yes, matched. That means 3 rows processed and 2 rows selected. Now this row is already joined with all 3 rows. Next, take this join with all. First sample not matched. Remove it. Remove it. Second sample, yes, matched. So write the entire row. Next, third sample not matched. Remove it. That means 3 rows processed. This is also completed. This is also completed. The last one joined. First sample matched. Second sample not matched. Third sample matched. So 2 rows selected. Like this, I processed 9 rows and selected these 5 rows. That means first row will join with all 3 rows. the condition to be applied now, condition to be applied now, then select it. That means this row is done. Next, continue with this row. Likewise, you have to do it with the row by row and then directly write the result, of whatever was. That is how you have to perform the join. Clear, guys? Yes. Now continue with the next question. This was given in GATE 2004 for 1 mark. Please read the question. It is a schema pertaining to students database. Look at this. Whenever they say student database, primary keys, foreign keys, all are existing, guys, because they fetch this table from the existing database. So all constraints will be built in. On top of it, they have written it is a primary key, it is a primary key. Underlined will be primary keys, guys. Look at this, they mentioned. What they want? How many rows are there in natural join, they are asking. Please pause the question and then go to the solution. Yes. Here is the question. Student table, the primary key is roll number. It is a simple primary key. Has 120 rows, very good. That means 120 students are there. And enroll, how many students enrolled? Here it is a composite foreign key. Whenever I say composite primary key, individual columns won't take null values. Please remember that. In case of composite primary key, I explained 3 concepts. Individual columns won't take null values, combination must be unique, and individual columns can have duplicates, 1 C2, 1 C3 likewise. So it won't take null values, please remember that point. And 8 rows. Now tell me which one is the child column? Parent column must be always the primary key. That means this roll number is a child column, this roll number is child, referring to that. Now, the child table has 8 rows, parent table has 120 rows. You know, on top of it, the child column is not null as well because it is a part of primary key. It is a part of primary key. Now you know, whenever foreign key is not null, the minimum and maximum always comes from child table, always comes from child table. If foreign key is not null, minimum always comes from child table. Child table will have 8 rows, parent table will have 120 rows, child table it is foreign key plus not null. So natural join, minimum maximum will be always 8. Following, guys? The same concept I explained directly in key points of the joins concept. Here they asked indirectly. They didn't mention that it is not null. They did not mention that because it is a part of primary key. It is a part of primary key. If it is a part of primary key, it won't take null values. Then you have to assume that it is foreign key plus not null. So this foreign key won't take null values because it is a part of primary key. On top of it is a foreign key. So all 8 students will be selected. So indirectly what they said, total I have 120 students and only 8 students enrolled the course. 8 students joined the course. So when you join, you will get all 8 students. Clear, guys? Now, please go to the question. This question is given in GATE 2015 for 2 marks. It is also pretty easy question because 2 tables are given. Beauty is with the data and they have been asked to execute this query on these 2 tables and finally give the number of rows. It can be 10 rows, number to be given. Now look at the beauty, guys. In this question, they applied 2 things. One is equijoin and other one is the group function. So 2 things they applied. So please solve the question. Equijoin and group functions, both concepts you are very comfortable. Please pause the video and continue with solving the question. Yes, let me continue. Yes, here 2 things. Now which one executes first? Where executes first? Next, group by. You should know the order of execution. So in Cartesian product, this row will join with all 6 rows. All 6 rows. What is the condition of equijoin? That one. When apply roll number equal to this, so among these 6, only these 2 matched. So once I apply this condition, then only 2 rows matched. So those 2 rows will be selected. So 6 rows processed for this done and selected these 2 rows. Again, this row will join with all 6 rows. Now this condition to be applied. Only 2 rows selected. Then selected. That means this row also joined with all 6 rows. Finally, 12 rows processed and selected these 4 rows. Now it's a last one. This is done, the last one, all 6. When you apply this condition, 2 rows selected. So finally, entire table joined with this entire table, and here is the result. Next one will be second, group by student name. It's not on number, guys. Student name will be this column. So how many distinct? Rohit is one set, Raj is other set. So I have only 2 distinct values, guys. So entire 6 rows will be divided into 2 groups, guys. One is Raj group, other one is Rohit group. Please don't execute the query blindly on roll number. If you go for roll number, you will get 3 groups. But the question is on student name. So it will be 2 is the answer, guys. Clear? Yes. Now look at this question. This has been given in 2018 for 1 mark. It's a pretty easy question, guys. They have given 2 tables with 2 columns each, and they have written one is inner join is nothing but equi-join, guys. Inner join is nothing but equi-join. It's a inner join. Other one left outer join. Query 1 is equi-join. Query 2 is left outer join. Query 3 is right outer join. Query 4 is full outer join. So likewise, they used 4 types of joins. One is equi-join. Query 1 equi-join. Query 2 left outer join. Left outer join. Query 3 right outer join. Query 4 full outer join. Now they are asking which of the queries above is certain to have output that is superset of other 3 queries. So among these 4, one is a superset of other 3. What is that? Among these 4 queries, one query is superset of other 3. What is that? It is nothing but full outer join, yes or no? Full outer join consists of equi-join rows plus free rows of left table plus free rows of right table. So full outer join is the superset of all 3 queries. It consists of rows of equi-join plus free rows of left table plus free rows of right table. So answer will be query 4, guys. If you are not confirmed answer, please look at this. It is the equi-join, guys. If you take this sample, equi-join consists of 1 row. It is left outer join. It consists of this free row. It is a right outer join. Now this plus this will be given this one. So full outer join, that is, if you perform, all rows are available in this one. So full outer join is a superset of all 3, guys. Answer will be D, guys. That is the superset of other 3. You know natural join. Before next question, I want you to repeat again. You know natural join, you know full outer join. What is full natural outer join? It is natural join plus free rows of left table. This is participated, this is participated. Free rows of left table, that is 3, 7. Other one is null. Free rows of right table, that is 4 and 9. Other one is null. That's it. Free rows of left table plus free rows of right table. That's it. The same question they have asked. Look at this. This was given in GATE 2015 for 2 marks. Question is easy, guys, but the way they asked is a little tricky. That's it. Look at the question. They are given 2 tables, small tables, one with 2 rows, other one with 2 rows. Now they asked you to perform R of ABC is a full natural outer join. Once you perform full natural outer join on these 2, which rows are available among these? They have asked. First, forget about the question. Please perform full outer join. Full natural outer join. Natural join plus this one is matching. Yes, rows of natural join. This participated. So this is free row, it is free row. We understood this. Plus free rows of left table plus free rows of right table. That is A will be 4. A will be 4. C will be 9. Please write here. And this will be null. That is full natural. This is called full natural outer join. Now the question. Among these 8, which one is available? 1, 5 null, do you have this? No, null is not there. 1 null 7? No. 3 null 9? No. 4 7 null, do you have anything like this here? No. Do you have 1 5 7? 1 5 7, yes, I got it. Do you have 3 7 null? 3 7 null, yes, I got it. 4 null 9, yes, I got it. That means only these 3 records are existing. This entire A, B, C, D are not available in the final set. That is the question they have asked. So only E, F, G. R contains E, F, G but not A, B, C, D. Clear? Yes. With this we are done with joins, guys. So only concept to remember in joins is Cartesian product, guys. Comfortable?